Welcome everyone. Thank you for joining us today's Minitab web demo. Today's topic is Minitab Statistical Software, Design of Experiment, specific in Factorial Design. Okay, I'm Nur Sulawati. I'm the Technical Support Specialist at Visit System. Visit System is an independent local representation for Minitab product and training in Malaysia and Singapore. Okay, so before we get started, I have some housekeeping item. If you have question during presentation, please type them into the question box in your control panel. You may send any time throughout the presentation, but I will address them during Q&A session and the end of webinar. So hopefully if have question, please type them into the Q&A session. If I don't have any time in here, I will email directly to you. Okay, kindly ensure that you have connected to the audio via your computer speaker. Please fill out our survey before you exit the tab. This survey will help us to improve the quality of our upcoming webinar. For information, in this webinar will be recorded and therefore it will be set listen only mode to avoid interruption to the audio recording. The recording will be accessible anytime later on our website www.visit.com or by subscribing to our YouTube channel Minitab Malaysia and Singapore. Okay, Minitab was developed in 1972, and then I think most of our participants today is quite familiar with the name. Okay, though this one is the software package for analysis, let's say for quality side, for modeling side, something like business analytics, and then maybe for reliability engineering, and then statistical software. Minitab statistical software is powerful. Everyone can use, whether you are a statistician or non-statistician, whether you are not data sciences or data sciences, and then they guide you these to answer with the available features inside there. And then now from anywhere on the cloud with the starting with the Minitab 20, now we're able to open in anywhere you go because now we on the cloud version. Okay, so this one is example tools available in Minitab statistical software. We have a measurement system analysis. We have a gauge study, gauge R&R, repeatability, and then we have a linearity because in the MSA we not cover only precision. We also rely on the accuracy part. And then we also have a control chart, not the only for S-bar chart. We have something like a T chart, ENWMA, something is advanced control chart also available in Minitab. And then of course, I think most of you familiar with the capability analysis. And then for information, this capability analysis, we call it as capability spec, where is our flagship product for capability analysis. And then for reliability engineering, also we have those, let's say for probability analysis, so accelerate live testing, MTBF, and so on. Also, we have for product development. So today we focus on this topic on the design of experiment. So in here is something features inside the Minitab available for design of experiment. So here is we call it counter plot. If I have time, I will show to you how to using the counter plot after you get the main factor contribute to your response, so we can go for the counter plot. And then we have a main plot. Since we have we assess 2 or 3 factor inside the factor or parameter. Maybe all of you using term parameter. Maybe every parameter or every factor, they provide to high level, low level. So which which level is more important into your why, your response. And then inside there, they provide the Pareto chart where you need, where you easy to you identify which factor are significant into your response. Okay, so this one is the business analytic. So I think almost of us know about the machine learning, predictive analytics. So all that thing also available in Minitab Statistical software with the new enhanced, starting with the Minitab 19. For example, for the cut, is a classification and regression tree. So it's something like regression. If let's say you are familiar with regression, so this one is alternative. Let's say your data is a big data, your data is have missing data, your data have a lot of outliers, so you can go for the cut. And then we are available for the time series, or you want to do the forecasting, we can go up to the ARIMA model. So for the process validation also, we know we have a 3 stages of the validation process: the process design, process qualification, and then continue process validation. So all these are available in Minitab Statistical software, but in different step menu button only. Okay. So this one is our user, not limited to the manufacturing, but we have a variety of the company. Also not limited for the big company. We also have a SME company using the Minitab Statistical software. Okay, so today our agenda is we go for the overview of design of experiment itself. Inside this design of experiment, we have a lot of design. So today we focus on the factorial design only. So in the factorial design, we try create the design using the Minitab Statistical software. After that, we assume that we do the experimental. After we get the result from the experimental, we do the analysis because we want to find the most factor or the most level important into your why. And then we need to know how to visualize that result with the factorial plot. And then of course, after we know this, or because we want to do optimization. I think optimization is the last portion in the quality side. If let's say you are coming from the quality, and then we try do it design our experiment using assistant menu button. Okay, so hopefully we can cover all this in 1 hours. Okay. So as we know, DOE consists of a series of runs or tests which purposely change are made to the input variables, meaning that now we not rely on one-to-one factor. One, maybe we have a 2 factor, but inside the factor we have a level. So for example, we have a temperature not only 30, maybe we have a lower and higher. Also goes to for something like volume, maybe we have low, we have higher. And then DOE helps to investigate the effect of input variable, or we consider the factor, or sometimes we call it the parameter, on the output or response at the same time. So we not go one by one. We do it all in all of the input variable, all of the factor variables you may get from your process. Maybe you start with the control chart first, and then after that you rely on the capability. From there, you do this something like brainstorm to identify your X and your Y. I think most of you know about the P diagram, which is where you get something like something like this one. Okay, sorry. This one is an input. Okay, this one is a process. Okay, process. This one is output. So from here, from P diagram here, you can access your input. What is your input? So input meaning that is your factor here. And then your process, and then what your output. So refer for your Y. Maybe here is your X. So from rely on this process, you know what is your input, what is your output. Okay, so Minitab used to determine which factor have a significant level on your response. You identify the effect of interaction between two variables. You want to optimize the process performance. You want to reduce time for the new product. Maybe you want to reduce variation in a process. And then maybe you want to determine the optimal setting of factor that optimize all the response, including safety and costing. Okay, so all this one, you want where you want to apply the DOE in your work day to day. Okay, so before we get further, so this one is some terminologies we need to know. What is the what we call it outcome or response? So this one is considered the aspect or measurement you are interested in improving. So measurement here can be something like variables you can measure is a decimal point, let's say length, diameter, something that one, or maybe can be accept reject. So DOE also applicable when your Y is attribute data is accept or reject, yes or no, go, no go. So it also can do it using the DOE. Okay, so is another term is we call it factor or variable. So things that you actively change to influence the outcome. So for example here, we have something like simple experiment. Okay, during we at the secondary school, maybe we have a boiling the water. Okay, so our response on this case is time of boiling. So time in the minutes we want, and then we try with the our factor. We have three with a type of pot, your electrical heat, and then your lid with a lid pot or leave it one open pot. Okay, so this one type of pot, maybe your material is a glass, and then others one is considered that metal. And then for the electrical heat, maybe it's a low, maybe considered at 20, something like one. Or this one is a higher, maybe 80 Derajat Celsius. And this, okay, so all this one type of pot, electrical heat, the lead is we consider is a factor. So glass metal, we consider that is a level, setting of each factor in the study. Okay, so for this case, we have a two factor. So we have a two factor here with the how many, sorry, you have a two level, low and high. So how many factor? We have a three factor. So which is now we have a equal to 8. So here is a level. This one is the our factor. So if let's say you have 4, so 2 power of 4 equal to 16. So 8 and 16 meaning that is your run. How many run you need to do the analysis, do the experimental. This one is not considered replication or repetition also. This one is just theory behind the factorial itself. Okay, never mind. We go for the next stages is the guideline of using the DOE. So something like the step how to do the DOE. So same thing, you need to define your problem and your objective. You choose the factor and level of the study. What we say that we have a 30 factor, we have a 2 level. And then you need to determine the appropriate response and how to measure it. Okay, make sure you know how to measure it. Okay, and then you need to have a determine the appropriate is experimental design. Okay, because we are a lot of type of experimental design, and then after that you run the analysis. Okay, you do it the experimenter, and then you run the analysis side, and then maybe I'm not sure this one is it you practice or not this one. Okay, you need to verify the result using the confirmatory run, and then after that you go further make a recommendation side. Because from here, you know which factor is influence to your Y. So from there, you can do it something like just verification your finding from the first experimenter, and then after that you go further make recommendation. So if let's say we think that and then we see this guideline, it's not only one day you can finish all this experimenter. So that's why the OE is something like reflect to costing, reflect to time. So that's why we have something like repetition or replication. So it depends on your costing and then depends on your timely. Okay. Sorry. Okay, so all this one, and then okay, so this one is a experimental design include in the available in the Minitab Statistical software. So we have a screening design, which is screening design something like you want to do experimental, roughly experimental. Let's say you have a 15, we have a 10 factor. So you not know how to setting your level, which one is a bit lower, which one is a bit the highest level. So you can go for the screening first. After you screen your design, maybe you can choose for the factorial design. If let's say you already decide how many level you have for every factor. Okay. And then if let's say during you do the experimental, you do the screening design, maybe you realize that you have something like curvature in your Y. Okay, curvature in your Y, so you can go for the response surface design. This one is a good one. I think all the real life we're using for the response surface design. Okay, and then we also have a mixed design. Whether is we have a two factor, we have a one factor, we have a two level only. Another factor, we have a three level. It's we call it mixed design. And then we have also Taguchi design. Taguchi design is most, you consider that the noise factor in your design also. Okay, so for the Taguchi method, something like is, if let's say we want to reduce number of run, so we can go for the Taguchi design. Okay, rather than factorial design. It's the last number of the experimenter. Okay. But today we just rely on the factorial design. But inside the factorial design itself, we already we have also after, I think this. Okay. So this one is a type of a factorial. I go after this. So what is the factorial design? Factorial design allow to simultaneously study the effect of several factors on a process, okay, varying level of the factors simultaneously rather than individually. Okay, factorial design to efficiently estimate the effect of each factor on the response. So estimate the effect of interaction between two or more factors on the response. So, or you want to test the curvature in the response by including center point in the design. So basically, design here is combination your experimenter. So we, for example, you want to start which experimenter you want to start combination for. We go back to for this one. So the first experimenter we want is the type of pot, hourglass. The electrical head is a low, and then our lead is a lead pot. We are the first experimenter. Second experimenter, we want a type of pot is a glass, but electrical head now is the height, and then for the lead is a leaf open pot. be our second interaction. Second experimental. So if let's say you have a 2 power of 3 for this case, let's say you have a 8 run without repetition, without replication. Okay, now you need to run with the 8 run. So the factor and the level during you deciding is an impact to how many experiment you want to run. Okay, so this one is, we call it the experimental design. So different design here have a different approaching. But today we just focus only for factorial design. So inside the factorial design itself, we have a type of design. The first one, we have a full factorial design, measure response at all combination. Okay, so applicable for, if let's say your number of factor 2 up to 50 for Minitab Statistical software. And then we have fraction factorial design. Okay, measure the response for a subset of original full design, run factor at 2 level only. So if let's say you have a 3 level, you cannot go with the factorial design, fractional factorial design. Okay, because this one is the applicable for 2 level only, high and low. If let's say you consider that high, medium, low, so not applicable for fractional factorial design. And then we have a split plot, and then bracket Berman also is for 2 level design. Okay, 2 level. And then for general full factorial, you can run the factor at 2 up to 100 level. So this one is the factorial itself. Okay, so this one is a number of factor if applicable, available for each type of design here. Okay, so this one is depends on your number of your factor, number of your level to decide which design is suitable for your cases. Okay. Is the narrow one, if let's say full factorial, measure response at all combination. And then general full factorial is starting with the 2 level up to 100 level. Okay, so basically if Blackett and Berman and the Blackett Berman, mostly we go for the screen design. Okay, screen design. Most of the researcher using Berman during the screen design. Okay. And then this one is the 5 reasons why factorial are successful. Okay. Use factorial and fractional factorial design are most cost efficiency. Okay. And then factorial design estimate the interaction of each input variables. Okay. So for example, you have a two factor A, B. So you can consider that interaction between A and B. Okay, you imagine now you have a factor 2, you have a plus, minus refer to higher, higher and lower, plus, minus, higher and lower. Okay, so the first one, you see that A plus, B plus. Okay, and then you see that A plus, okay, B minus. So A minus, B plus. So A minus, B minus. So 2 power of 2 equal to 4. So this one is combination. Okay, so we consider that also interaction between this A and B. Okay, and then factorial design is orthogonal, and then factorial design is encourage you comprehensive approach to problem solving, and then 2-level factorial design provide an excellent foundation for a variety of follow-up experimental. So I think if let's say you go whatever training part, they introduce the factorial design. first before go for the response surface design and so on. Okay, this one is a basic design experiment. It's starting with the factorial. If let's say you more explanation of this portion, so you can go to our blog. It's a 5 reason factorial experiment are so successful. So they have elaboration for each 5 reason inside here. Okay. So today we have something like we want to try create the factorial. We have a problem. Okay, manufacture of cake mix must determine the recommendation, baking time, and temperature to the print on the box. Okay, so meaning that now they have a two factor. This one is a baking time and the temperature. So the food sciences replicate a full factorial design with the twice. So they using two replication. So they bake all the cakes in the single oven in a single day. So meaning that no blocking. So for example, you have something like uh, morning experimental, night shift experimental. So it's we call it, we consider that have a blocking. Okay, and then they bake the cake for 30 minutes and 50 minutes at the temperature 3 to 5 Fahrenheit and then 375 Fahrenheit. So the scientists calculate the moisture content by measuring the mass of the material before and after baking. So I think easy to, we go to the Minitab. Sorry. Okay, so we go for the Minitab side. So we try to do it or create the design itself in the Minitab. So where? So most of the statistical tools, we need go for the stat. So stat, go to stat, DOE, you choose factorial design, create factorial design. Okay. So if let's say before that you create in Excel, also you need to declare first before you go for analyze part. Okay, so create the factorial design. So for this case, we have a 2-level factorial. Okay, we have 2-level factorial, 2-level split, pocket general factorial. So for this case, I just proceed with the default. And then we have a 2. And then you click to display available design. So you can see that here is a factor up there here. So factor. This one is the run. This one is the number of the run. So let's say you have a 2 factor. So you want to go for the full. So meaning that you need to do the 4 run. So if let's say you have a 3 factor, so you go for the full, you need to go for the 8 run. Okay. So if let's say this one is this column for the factor, this row is for the run. How many run? For this case, I just proceed with the full and then click OK. Then you click design. Okay, for factorial. So again, if let's say you have a replication, for this case is they replicate for 2 times. So you choose 2. Okay, so if let's say you have a block, morning, or you have different oven, so for this case just only 1, so you proceed with the 1, click OK. And then for this factor, maybe you have the name, you can rename the name of the factor is a time. The second part is a temperature. Okay, so this one is only okay. Our low, maybe you consider that this one is the 30 minutes. This is 50 minutes. Okay, so this one. This one is the, you can proceed with the default setting only, but easy to see, we do it one by one. After this, you can see it 325, 375, and you click OK. And then you click OK. Okay, so now you get this one. I will do, go to stat, go to DOE, you choose factorial design, create factorial design. You choose what type of your design, how many factor you have. You can display which one you want. Okay, proceed this one only full. And then you rename you rename your factor and their level, okay, and then click OK. So you get the result here. So design is a 2 factor. Your run is a 8 run because you have a 2 replication, and then you have no block. And then in your worksheet, you get this result. Okay, you get this one. You get this one. So we have a 8 run. So from here, you can see that it's a standard order. This one is a run order because we choose the random, the default setting is a randomization. Okay, the first order. Okay, so you can see that the standard order here is the 30. This net time is a low level. Is a temperature is the low temperature. So the second one is the time is the higher, the temperature is the lower. So and so on up to 8 run. Okay, so meaning that now after you get this design, you can do it the experimental. Okay, so your Y for this case is a moisture. So you can run the experimental after you get this combination. This one is important. Okay, so this one is, we call it experimental design. If let's say you're using this kind of approaching, so we consider that this one is the design of experimental. Okay, so we go for this one is just, okay, so this one, okay, but of course you see that is we have a color code here. It's a green color, we have a yellow, we have a red color. So green is best resolution, meaning that you do it the full factor design without a, we have a 2 factor, you have 2 levels, so you need to run 4 run. But if let's say you go for the factor, we have a 3 factor here, you have a 2 option, whether you want to using 3 resolution, mid-range, poor resolution, resolution 3, or you can go for the full factor, full design. Okay, so this one is the way call it. For each resolution, the size of interaction that confounded with the main effect in one less than the resolution number. So this one is half from here. Should be 8, but you don't have any time, you don't have any cost, more cost, because you go for more run, okay, the more costing. So you can have option go for the 4 run, but this one is the resolution 3. So some combination they confounded just only, for example, factor A can be assumed as a interaction between A and B only. They consider that is the same thing, can be only one experiment, okay, one experiment, but can we call it what? We parallel to others interaction. Okay, is we call it confounded. Not all the experimental, just only one maybe have this one. Okay, so but this one is a depends on your costing, depends on your timely. Okay, so this one is, I think already do it. Okay, so after we get the experimental design, we have come up with the experimental, and then they want to find the factor setting that result in the mean moisture content of 26 plus minus 1%. So the last aim after know which factor, whether is a baking time and temperature is the most important, and then they need to know which time, what level of a time they need to write in the box, whether it's 30 or 50 minutes. And then also goes for the temperature, whether it's 325 or 375 on the box. Okay, so we go to another way. Okay, I think it's okay. So now you consider that now we already done our or run our experiments, and then we get the our moisturizer. Okay, this one we already done it. Okay, so go to Stat, go to DOE, go to Factorial, and then you choose Analyze Factorial. Okay, so if let's say your Y be something accept, reject, yes, no, so go, no go, so you can go for the binary response. This one is the new one, starting with the Minitab 19. Okay, so go for the analyze factorial design or analyze variability, meaning that you have a repetition, not the replication, repetition. So uh, the first replicate, the second one you repeat again measurement, not the run the experiment, but you repeat the measurement. Okay, so you can go for the DOE factorial analyze variability. You have one Y1, Y2, Y3, and so on. So you can go further, analyze variability. But today we just using the replication. Okay, so we go for the factorial design. Okay, so our response here is our moisture. And then we have a terms here, just only model up to 2. 2 here is a refer to factor, which is baking time and temperature. If let's say you have 3, so they up to 3. Okay, and then this one is you select which one you want, or you don't want interaction, you can remove. But for this case, we want interaction. And then you click OK. After that, you go for the graph. Okay, you choose the effect, and then we choose the 4-in-1. Okay, the 4-in-1. Click OK, and then you click OK. Okay, click OK, and then you click OK. Okay, so now you get the result. I will do, go to Stat, go to DOE, Factorial Design, you choose Factorial Design, you choose your response, you go for the graph, and then you choose the 4-in-1. Click OK, and then you click OK. So now you get the result. Okay, so based on this one, we go for the R-squared here. So R-squared is quite good. Okay, 87 is quite good. And then you go here for your analysis part. So you see that this one is a less, all this one is a less than 0.05. So all this term is a significant into our Y, our moisture. Okay, and then after that you go so here also have a significant. And then most important here, you need to checking your assumption. Okay, you need to check your assumption before you accept this this equation is a good for you, or this ANOVA is a best to you. Okay, if let's say it's not best, you need to run it again. Okay, once you get this one is a good one, okay, is straight line, and then have a constant variation, okay, and then rely on the scatter in between 0. So your constant and your mean, your variation and your mean is a constant. Because this is 8 run only, so 8 data set. So for this case, histogram is not good to in term determine the normality of this residual. Okay, so you can see that you have this one, but just not because only have a small data set. Okay, so go for this one is a good one. So all this is acceptable now. So meaning that temperature significant, your time also significant. Your interaction between temperature and time also significant. So almost all the term is the importance. Okay, so this one, okay. Okay, so since almost all the time time and temperature is a significant, interaction also significant. So meaning that now we need to find which level for each temperature and then for what level for the time. Okay, so we go for the factorial plot. So we go for the factorial plot. Okay. So go back the same thing. So go back to stat, TOE, factorial. You see that factorial plots. Okay, factorial plots. You choose the factorial plot. Okay, so all this one, and then you click OK. Okay, so this one I will do. Go to stat, TOE, factorial. You choose factorial plot. Okay, and then you choose this one, you get the result this one. So based on this one, the highest moist is the temperature with the 3 to 5 is the highest one. Okay, and then for this case, for the time, factor time, 30 minutes is the highest moisturizer. So factor setting is this two. Okay, temperature at 3 to 5 and then time at the 30 minutes. Okay, so after that, we can go for cube plot. Okay, cube plot is something like you want to show the relationship between the factor and your response. So each can show the three factor. Okay, you can show three factor because this time around we just play with the temperature and time only two, so you can get the rectangle cube plot only. Okay, so if let's say you have a 30, we have something like 3D. Okay, for the cube plot here. So we go to this one to do the cube plot. So go to stat, go to, sorry, TOE, factorial. So you can go for the cube plot. Okay, so the fit means, and then this one is select, click OK. So you get the cube. So based on this, so you can see that which value is the highest one. This one is it 37%. So meaning that is a temperature is 3 to 5. Your time is 30. Okay. Or another portion you can do it for the visualize this setting. So you can go for the stat, go to DOE, go to factorial, go to counterplot. Okay, so between this one we have a temperature and then click OK. So you can see that this one. Okay, so this portion, if let's say you want more higher moisture, so you can go for the less level for the temperature, and then the minimum number of time is 30. So you can see that this one is change it, the color change from here to here. Okay, it's a dot. Here is the highest. Okay, so this one is the way we do it, visualize our setting. Whether you can using cube plot or you can using the counter plot. Okay, after you get which factor is important. Now we rely on the which level is important. Okay, so we go another one. Okay, this is last portion. Okay, for the optimization. So many design experiment determine optimal factor setting that produce the best value for a response of interest. So response optimizer use the most recent model fit to calculate solution based on disability criteria. A response can be minimized, maximized, or aim at the target. So back to this problem, they have a target. Okay, they have target lower and upper. So for the response optimizer, we go for the target value. So go to the back to this one. Okay, sorry. Okay, so go this one. So back to the DOE again. Stat DOE, go for the factorial. You choose response optimizer. Okay, so for this case, we have the target. Okay, we'll set up. Sorry, 26. So our setup is the lowest, 25. 37. Okay, and click OK. After that, you click OK. Okay, so you get the optimizer. So if let's say you go for the setting this, your fit, okay, is 26. And then your confidence interval for this case. Okay, because we already have our target on the target side. Okay, so you get this fit is 26. So what level? Temperature 375. The time is 33.58. Okay, so I will do go to Stat DOE Factorial. You choose Response Optimizer. For this case, we go for the target. So if let's say you got target, you need have a upper and lower. Okay, upper and lower. You click OK, and then you click OK. So you get the Response Optimizer here. So our D here, you see that the one is the good one. Okay, so you can do the prediction after you get your regression equation. Okay, so this one is the response optimizer. So from this, you can see that we can create the design. Okay, we create design, this one. Okay, after we create, we run the experiment, and then we analyze the experimenter. We get that all this term is a significant. Okay, it's significant. So temperature and time is important. Interaction also impact to this experiment. After that, we need to know which level for each factor are significant into the response by the factorial plot. Okay. After that, maybe we want to know more, finding more about this. We go for the cube plot. Okay, to visualize them. Easy to present to management or okay. After that, we can go for the response optimizer. You want to predict what happen if let's say you want your Y be 26. What happen? What setting for your factor and your level here. Okay, so this one is the step can you get or result you get once you apply the DOE in the workplace. Okay. So we have features inside the Minitab available also for DOE. Is we call it assistant menu. Instead, you're using the DOE stat DOE. You available also for the assistant menu side. Okay, so you can using the assistant so engagement. So I go to this one. Okay, so you can see the assistant, but is this one just like assistant, you need to plan and create also before you go for the analysis. You can see that is the not the black color here. Okay, so meaning that you cannot do it anything. You need to plan and create. For assistant, they provide you plan and create. Okay, so you can plan the screening experiment and then you can go for the optimization experiment. Okay, so you can create the screen design. So for this case, I create the screening design. Okay, so for the screening design, we start with the 6 factor. Okay, we can start with the 6 factor. That's why we call it, this one is a screening design. Okay, introduce or you want to study about your factor first before you go for the actual part, whether you're using the factorial design or response surface design or others design. This one is screening. Which one? Okay, this one is the effect into the Y. This factor also effect into the Y. So you include all your parameter or your factor. So you can go for the screening side first before you go for the real experiment. It's a good one. Okay, before you go for the actual experiment. Okay, for example, here we have a A. Okay, B, C, D, So you can get it the continuous, okay. So maybe this one is a P categorical, X, Y. Okay, so maybe this one is 20. This one is just a simulation, not the real experimental. Okay, maybe it's categorical, SRT, okay, okay. This one maybe, okay. So you click OK. So meaning that now is a total number of run in the design is 12. So click OK. So you get this one. Okay. You get the experiment design. So you can go for the experiment and then you get the result. You do the measurement here. Okay. You do the measurement here. For example, I just play around with this one. Okay. Okay, maybe this one. So you go back to the assistant, DOE, analyze and interpret. Okay, so analyze and interpret. You plan, optimize. Okay, so they give it you this one. What is this one? Okay, you are how to identify the factor. So you can define your factor level. What is the sample size? Okay, sample size here is referred to the how many run, and then this one. Okay, so you can delete. So identify 2 to 5 factor, did not 2 to 5 this factor. Okay, so you can go this one, also this one. Okay, so you can also using the assistant to do the DOE, but I'm not only suggested for do it all using the assistant, because it's something like you need to have more knowledge on that, because you will confusing about the design itself. Okay, how many run is the differences. Okay, but they using the same theory, but you need to go one by one using the assistant menu. If let's say you want to go for the DOE, because assistant menu is just like help you if let's say you not remember all the thing, so they give it you tips. What is this factor? What is the level? Something that one. Okay, so if let's say you want more, you need to, I advise you better using the step DOE or Factorial. So you can see that all these one are available inside the DOE. Okay, inside the DOE, all the design the same thing. You can predict, you can do the Factorial factor, you can do auto plot, you can do the response optimizer, all in the menu here. Okay, this one. Okay. So from that one, the differences between assistant, they provide you the summary report here. They provide you the diagnostic report, okay, and then they provide you the screening report. So they have something like color code here, okay, so easy to see which one is the important. So gray color is here. Gray color here is not important into your Y. Okay, the gray color here. Okay, so this one is the differences between using assistant and then using the step menu button. Okay, so do what we have a Q&A session, but I think we have left only 4 minutes. Okay, so I go, if let's say the one. Okay, the first question is, I think I cannot answer all this. If let's say I have, I will email to you after this. So I go for the Dennis first. What is the purpose to do the replication or run? How many replication run is Sufficient. Okay. So basically, it's the ones is a depends on you. Okay. Depends on your budget. Depends on your time. Replication meaning that now you have one, only one replicate. Maybe we cannot we say that is confirm it that the response or the number of experimenter is not reflect to the number of your factor. Okay, sometimes we have a interaction. Okay, sometimes imagine you have a 30 factor, so which is you have A, B, C. So you have interaction between A, B, B, C, A, B, C. So if let's say you do it full factorial 8 run, but you just only rely on the 4 run. If let's say you're using the 3 resolution. So A, B, interaction between A and B, B and C, A, B, C is confounded to the main factor. Okay, so that's why most of researcher using the replication. But maybe the best thing is the 30 replication. But I think one is the time and then based on your costing to do the replication. Okay, replication meaning that you need to have run 1, okay, up to run 8. After finish all, you replicate another one. Okay, so this one is the meaning of the replication. You want to assess about the variability inside there also. Okay, and then what is the differences between full factorial design and RSM? What do I should use for the, okay, so RSM when your Y, your response is have a curvature. Okay, something like it's not the straight line. You have the something like cubic or you have inverse. Okay, your Y is not the Y. Maybe it can be a Y power of 2, Y power of 3. So you can go for the RSM. Okay. I think others question I will email to you. Okay, I will email to you because we have done enough time to answer all this one. Okay. So if let's say you want this material, you can drop your email in the Q&A session or in the chat box. And then if let's say you want have this recording, I think after this they will upload into our YouTube channel. So you can go to YouTube channel, Minitab Malaysia and Singapore. Okay, so thank you guys. If let's say you want to try or buy, you can visit www.minitab or www.visit.com. If let's say you want to ask about the training for DOE, you can contact us minitab@visit.com or sales@visit.com. If let's say you want to support us, so please, or you want to know about our next event, something like workshop, virtual workshop, and so on, or public training or training in-house. So you can follow us through media social, which is follow us in the Minitab Malaysia and Singapore for Facebook and link. So you can scan here. So thank you guys and see you again with the different topic. Stay safe.